Hey everybody, this is going to be a quick overview on Cassandra. It's something I've been playing with lately. I've really been impressed with what it can do, and so we're just going to jump in and start talking about it. A few things that you may want to know about Cassandra basically are it was created by Facebook like in 2006, I think. Anyway, it was open sourced by them in 2008, and the Apache group has picked it up. The Apache Foundation has picked it up and has been maintaining it since. And basically what you get out of it is it's a columnar or column-oriented database, and we'll go into what that means here in a minute. But the big things that people like about Cassandra, and you'll see some of it down here, is the fault tolerance, which basically means that it replicates your data to multiple servers or nodes, and by doing so, if one node goes down, it'll just query the other nodes to find stuff. You can set that fault tolerance as high or as low as you want, and the trade-off is that every time you do a read, if you have it replicating to too many servers, then it'll take a little longer because it has to pull all those servers and make sure that it has the right data and update those servers so that then they have the right data. What's really nice though is that you can send your queries or whatever to any node in the cluster. And the other thing is that because you can set up a cluster and add servers to it easily, you can scale up in a pretty straightforward manner. And that's usually what they recommend for people, is that if you're looking to scale up in that way, then Cassandra is good for you. If you're just going to do a one server database, then Cassandra might not be the best fit for you, because your real value is in the replication and clustered services that allow you to scale up quickly. If you're going to download Cassandra, I made the mistake the first time of downloading the source package, which is similar to this. If you click other download options, you can find them, but it's a -src, and then I tried to compile it, and that didn't exactly work for me. But I picked up the bin package the next time I tried, and if you go and pick it up here, you'll find that it has a lot of things in there that are really good for you that can help you out. Now, the way that I'm going to be accessing Cassandra is actually through the Cassandra gem. You can find information for it here at github.com/fauna/Cassandra, and that will get you going pretty well. So like I said, I'm using Apache Cassandra 081, which is the latest version. And if you look here really quickly, you have a couple of folders here. The ones that are really the ones that you want to know about are conf and bin. And so if we list the contents here of conf, you'll see that this cassandra.yaml, that tells it where to store all the data, and a bunch of other things like that. You can also set up, I think it's schema-conf.yaml, and you can actually define your schema or predefine your schema for your cluster in there. I haven't been doing that. I've actually been using the command line interface and the tools in the gem to manage my schema. And you know, since it stores all the data, it'll actually just pull it back up and persist it that way. So it hasn't been a problem. So let's see, one other thing that we want to do here is show you what's in the bin folder. The bin folder has some things in here that you're probably gonna want to know about. The Cassandra executable obviously starts the Cassandra server. Cassandra CLI is a command line interface that allows you to access Cassandra, and I've played with it. The problem is that I didn't find it super useful, because basically what happens is you put your data in, and then it gives it back to you in byte arrays, numerical byte arrays, and they're just, you can't see the data to know whether or not what you're getting back is what you want. So I've actually been using IRB with the gem, and that seems to work really, really well. So let's go ahead and start Cassandra real quick. and it looks like it had a problem here. Oh, that's right. I opened it. I ran it as under sudo once, and so now it can't access the data. Or when anyway, I deleted the data, all the data once, and then when I started it again, I actually have to run it as root now to access the table, or the tables. Or anyway, they're not tables, they're key spaces, and I'll get to that too. So let's go ahead and fire up IRB. And then what we can do here is we can actually access this data store. So I'm just going to call it store. And you just call Cassandra.new, and then you can put a key space in here that you want to access. Oh, acquire Cassandra. You can just get that by gem install Cassandra. So then if we run this, you can see that we're connected. This server configuration is the default. It's the default for Cassandra when you start it up to run on port 9160, and it's the default for the gem to connect to localhost at 9160. If we look at the schema, then you can see here that we have this ks-def. KS is for key store. And you can think of the key store as kind of like your relational database. And it's kind of a handy representation. It's not exactly the same as a database in your relational database schema, but for our intents and purposes right now, you can think of it that way. So it's just a large collection of column families that you can modify and use. So the first thing that we want to do is set up a column family. Now a column family, you can think of it as kind of a table, but only in the sense of it's the next biggest container. And what we need to do here is we actually need to create a column family definition first. So cf-def, and then Cassandra thrift. No, it's just, yeah, Cassandra diff thrift, and then it's cf-def, and cf is for column family. .new, and then you pass it a key space that you want it to live in, and you give it a name. Now there's a little more to it than this because there are other options, and I'm not going to go over what all of those are right now, but you can see what they are right here. So you have key space, Twitter, name, users. The only other one that I'm going to mess with today is the column type. The comparator type, row cache size, key cache size, and read repair chance are things that I'm going to go over in another one, just because I don't have time in this particular demonstration. So let's go ahead then and add a column family with our definition here. So then if we look here, and I'm just going to clear this so that you can see it clearly, store.schema now shows this key store, but within the key store it has cf-defs. And you can see here that it's a key space within it's within the Twitter key space. It's named users, and it's a standard column type. So then what we can do is we have the option of doing we can add stuff to our here, let me clear this. We can add stuff to our column family. So we can add columns. We can actually add rows. And this is what got me confused, okay? So what we have is we have this schema that we can add stuff to. So we specify the column family, and we specify the key. And since this is a Twitter clone, I'll just use my Twitter username. And then what we're going to do is we're going to specify the columns that correspond with that key. And if you think about this as schemaless database, then what happens is so the column families have rows, and each row has a set of columns, and the column, unlike the Twitter setup or unlike relational database setup, the columns are a key and a value. So a column is a key. So think of this as the key accesses the row, and you can think of the row as kind of a dictionary or a hash with values or keys and values in it. And the key value pair is a column, which means that each row can have its own set of columns with their own sets of keys that don't correspond to each other at all. So we can set one up here as Charles Max Wood and password dumb password, and then invalid because we called it users, if you recall. You got to spell them right. So then I think it's get keys. I don't remember. Anyway, we can actually pull it out this way. Store.get. I just wanted to show you that there was one key in there, but it doesn't matter. But if we do store.get, then you can see that it returns this ordered hash with the name and password in it. And you can also see here that it returns this smaller hash, and it has this reference information in it. So anyway, the next thing that we want to do is we want to go ahead and maybe remove one of the fields. And we could do that through, in fact, let me show you something else real quick. So if we wanted to change the password, all you do is you do another insert, because insert is both create and update. And so if we come in here and we say, whoops, I don't know what that's going to do. We'll see. Where am I mismatching on the... Okay. So we got it to error out finally. So store.insert users cmaxw and then password. So then if we do the store.get again, then you'll see that it just changed the password. It actually left the name alone. And that's because each of these pairs, the key and the value, is a column. It's its own entity, and it manages it all on its own. And this information right here, I just realized, is the timestamp for when that was changed. And that's used for accounting for differences between different nodes. All right, so let's go ahead and let's insert another one. I think that's Ryan's Twitter handle. If not, you probably know who I'm talking about anyway. And let's just say that we're just going to put a password on him. Railscasts. So then, if we do a store.get, then you can see that it just returns the password. Now, here's the cool thing. I don't remember if this is multi-get or get. Users are Bates. It might need to be in an array here. There we go. So sometimes it has an IO error. You just got to try again. Anyway, so now you can see that you get an ordered hash, and you get CMaxW, and you get RBates. So you get both. And so you can do a multi-get, and it pulls them both out. Really, really quick, really fast, and really, really handy. So now what we want to do is we're going to go ahead and we're going to remove one of the values. So let's say that we're not using name anymore, and we decide that we're going to clear the name out. So store.remove. And then if we do our, I think I have it here relatively. So then if we go ahead and pull CMaxW, you can see that the column is gone. It's been removed. So that kind of gives you an idea of what's going on. Now, one other thing I want to show you is that you can also have a super column family. And to do that, what we'll need to do is we'll create another, let's see, CF def Cassandra thrift cfdef.new, and then if we come in here and we say key space Twitter name, let's call this one tweets, and then the column type is super, because they are super. So now you can see here that you've got this, it just changed this one value, and you can change any of these. The comparator type just gives you the sort order of the keys on your columns. That's all. So anyway, let's see. So then if we go ahead and jump in, and what were we doing? Oh, we were creating, okay, store, add column, family, CF def, then store.schema shows us that now we have two of them. We have two column families in here, and here's the other one. And you can see that this is the information we were looking at before. Twitter, tweet, super. So then in this particular example, then what we can do is we can do let's set up a tweet time here real quick. So then if we go ahead and we do a store.insert, and this time it's tweets, and keep in mind that these keys can be anything, and it just condenses it to a byte array and stores it to manage the key. So a super column family is basically a nested hash, or a nested dictionary. So we can have the tweet, and the body is Chuck Rocks, and let's say that we store the user ID on here as well. Now indexes work a little differently in Cassandra, but I will go into that in another episode. So argument key must be a string. Okay. In Cassandra itself, it can be anything you want. 2i.2s. So then we're just going to store it as a number. So then if we do a get, and I'm just going to clear some of this out here real quick. Then you can see that it gives back this ordered hash. Now you would think, and I'm just going to warn you, you would think that you can go ahead and do something like this. That won't work. Oh, it did work. Maybe it was the third level down. So you can get individual columns, but in super columns, there you go. So you can dig all the way down. Now, super columns are only nested to one level, so you can't add anything else underneath body. However, you also need to know that it expects that first level, that tweet, right here, let me highlight it. Right here, they expect this to have a value that is a hash. And so it's a nested hash. I haven't seen any examples where you can mix the two. So just to be aware, but you could actually then, let's say you were working with the tweets here and you have some kind of comment or like or star or something on here, then you can actually, you know, add another key under this. So this is the tweet, and then you have another key at the same level that is stars, and it'll tell you which users have started. I would probably do it a little differently because I'm probably going to have to look stuff up that way. So anyway, that's just an example. So let's see. To remove stuff, to remove a column, it's the same thing. It's the exact same syntax. So then if you try and get it, you get nil. If you go up one level and get that, then you see that it has removed the tweet deal altogether. Oh, I'm removing them. So that's what you get. Okay. So let's just add that back on real quick. And then go ahead and do the remove. And then there we go. So you can see that you're getting that same ordered hash. It only removed the one column. So again, you're getting this ordered hash with tweet and user ID, and you can actually, if you just make the assignment, then val tweet, you can see you're just getting that ordered hash, user ID, and there you go. So that's basically all I had that I wanted to show you. Pretty slick stuff. I'm still learning about Cassandra. There's a lot to know, but you know, maybe in another episode we'll jump in and we'll talk about indexes and sorting and sort order and all that stuff. But anyway, so this is just a real quick demo, and I hope it helps you if you're looking to learn how to use Cassandra with Ruby. Thanks. Need expert help with your Ruby, Rails, or Sinatra application? Give me a call. My phone number is 801-367-6164, or you can email me, chuck@teachmetocode.com. Thank you. Do you want to learn Ruby on Rails? Then sign up for my 6-week course at teachmetocode.com/Rails course. New Relic is the leading provider of application performance management tools for Ruby and Java applications. Thousands of companies use New Relic RPM to monitor, troubleshoot, and optimize applications deployed either in the cloud or in dedicated hosting environments. RPM Lite is free, fully supported, unlimited time version available at www.newrelic.com. All the leading Rails companies use New Relic, including 37 Signals, AT&T Interactive, Shopify, OurStage, IGN, and lots more.
That was wonderful.
Bravo!
I loved that.
Oh, it was great.
Well, it was pretty good.
Well, it wasn't bad.
Well, there were parts of it that weren't very good, though.
It could have been a lot better.
I didn't really like it.
It was pretty terrible.
It was bad.
It was awful.
It was terrible.
Get him away!